So welcome everybody to this latest video on A-level video on 160 maths, and in this video we'll be continuing with trig identities but working through some common problems. Now there will be a worksheet in the description below for you to have a go at these questions, and in this video we'll go through one variation of the solutions to get that proof. Now, trig identities are very common, and it's an important area of trig for you to work with, as it's combined with not only other areas of trig but also other topics in maths too, so things like integration, differentiation, etc. Now, trig equations where you have to prove an identity is very similar to those covered in AS maths in the previous video. However, the only difference here is that we're going to include the new identities covered in the previous video of cot theta, sec theta and sec theta. Now, to prove an identity, again, just a quick refresh, what you need to do is you need to make sure that you're using one of the following four proofs of proving this. So you're either going to prove that the left-hand side is equal to the right-hand side, or you can prove that the right-hand side is equal to the left-hand side, and also for other questions or identities, you can also prove that the left-hand side over the right-hand side is equal to 1, or the complete opposite of that, where the right-hand side is over the left-hand side is also equal to 1. So these are the four main ways you want to prove an identity. Now, the key thing to remember is that there may be more than one way of proving the identity. Now, as long as your working is mathematically correct, you will get the same amount of marks. So for example, if you wanted to go from A to B, you may get there directly in the shortest possible distance, or you may go in a completely wayward direction and eventually get to B. Now, obviously, the most efficient and the quickest way is going to be the quickest. However, it all depends on how your brain is thinking, and obviously the more types of questions you practice, the more skills you will develop. And obviously when you start looking at mark schemes and solutions, or you start asking for help, you may get encouraged to use or think about one particular area to focus on or to try before you try other things. But the key thing to remember is that there is always going to be more than one way. So if your answer is different to that in a mark scheme, or from a person sitting next to you, or from a teacher, as long as it's mathematically correct, you haven't done anything that's mathematically illegal, you're going to be absolutely fine to get the full marks. Now, before we get started working through some examples, let me just give you some top tips. Now, the first one I always say or suggest is that for you to design or make a poster with all things trig. Now, once I've gone through these steps, I will show you what I mean by this, but what I mean is to have all the trig identities there in front of you, write on a piece of paper, have it easily accessible to you, so when you're working through these, if you get stuck or need to double check what one thing is from another, then it's there accessible for you, a bit like a formula sheet. The second one is to learn all the trig identities fluently. Now, unfortunately, with the new A-level, that you're not going to get any of these trig identities given to you, so it is really important you learn them, and the best way to learn them is by persistently practicing questions or persistently writing them down, or if you see them, have them as your wallpaper on your phone or on a poster in your bedroom or wherever you work or study. It's just something that will constantly remind you, and obviously by being fluent in learning those trig identities will make these questions a lot easier and less likely to make any silly mistakes. The third one is tend to start with the side that looks more complicated and less simplified. When you get a trig identity question or a proof question, one side will seem more complicated than the other. Now, with the side that looks more complicated, you're more likely to be able to do more things with it. So always tend to go for that as start base and then move on to try and make it look like the other side. Now also, it may not always be the case of where you want to make the left hand side look like the right hand side. You may have to flip as mentioned, but also what you want to try and do is refrain from doing this. So for example, I've seen some students who have a left hand side, they do a bit of working out, then they get stuck and then think, right, well, okay, let's get the right hand side, and they do a little bit and then they realize that this step here is now the same as that there, and they say, oh yeah, then that's the same. Now the problem is that's not what they've asked you to prove. They've asked you to prove that this left hand side is equal to that right hand side. So if you do get to this kind of dilemma, then what I would always suggest is you start with this, write all of that, and then write from this stage upwards to make it look like the right hand side. If you are finding that you're doing this type of technique, then what you might be better off doing, or what you're actually explicitly doing, is proving this. So if you find that there's not much you can do with the left hand side or the right hand side as its face value, then what you might want to do is take one side to the other and prove that it does equal 1, in which things will start to cancel, or you'll come to a point where the trig identities and plus ones and ones come into play. Now the fifth step is also the fourth step is, again, as I mentioned, is only work with one side. Don't treat it like a double-sided equation, just like I've gone through here. So that's basically what this means. Try and work with one side, or just take everything all onto one side and prove that it's equal to 1. Now the fifth one is quite an important one, is particularly if you're working with someone or when you're in class, is that some identities to prove will take 20 seconds, some will take 5 hours. Some will take a couple of lines and some will take a whole sheet of paper. It all depends on how you go about it. It all depends on how you get from A to B. Have you gone through diversions? How many diversions have you gone through to get there? Now again, as long as it's mathematically sound, you're going to be absolutely fine. And if you can't prove, and the sixth one is something I really do recommend, is if you can't prove an identity, just step away from it. Make a cup of tea, go out, come back to it and start afresh, start brand new. Do another question, take a break and then return to it. Sometimes you just need a clear mind to think about things. As usually when you're doing one step, you can't think of any other steps to think of unless you've just forgotten about what you've done. And I'd still do it as a teacher, where if I can't solve an identity, I'll just wait a couple of hours and have returned to it, and I've mastered it, and I'll be thinking, why could I have not done this before? The seventh one is check you've written down the question correctly. I have massively suffered for this by working on Trig Identity to not be able to do it, can't understand why, ask someone, they don't know how to get the answer. I look back and I realise it's because I've written the question wrong. So just double check that you have copied things right, and sometimes when you work with the left hand side or the right hand side, just double check to make sure, take those extra couple of seconds to make sure that you have copied it correctly. Number 8 is make sure you show all your steps. Try not to do things mentally, just write everything down. The ninth one is, again, something that's very, very common when it comes to marking exam papers, is do not leave two versions. As I've previously mentioned, if you get stuck, start again, start a different way. If you started with the left hand side, then maybe start with the right hand side, or try the LHS over RHS method. But make sure that in an exam you do not leave two different versions of an answer, because if that is the case, the marker is not going to just pick and choose where you get your method marks. They'll be distinctive of which one looks more prominent. So make sure you do not leave two versions of a proof. The 10th one, again, is massive teacher pet peeve, is do not make up your own maths. Do not invent these identities. These steps do get checked. Don't think that, oh, if I just bit a bit of a waffle, no teacher's going to check if I've done 3 pages of working out. We do check, as particularly when it comes to exams, that will get checked. And if you've done something wrong, there's a good chance you're going to end up with losing more marks than you would have done had you done it correctly. And the last one is, once you've proved an identity, another question is, how do you finish these questions, or how do you write it off? Well, I usually enter with equals the right hand side, or you can use a bit of Latin, which is QED, which basically means quod erat demonstratum, which basically means that I have proved what I've been asked to prove. And sometimes just finishing off that, it won't get you any extra marks, it may make you sound a bit clever, but there you go. Now, as I've mentioned, the best thing to do when you're working, before you start working with Trig Identities and questions involving Trig Identities or proof, is to have everything all about Trig written down in front of you, either on a piece of paper, just so that when you get stuck, you can look at it, and hopefully that will give you some inspiration of getting this sorted. So the first thing we want to do is have something that looks like this. So for example, in AS Maths, we looked at that sine squared theta plus cos squared theta equaled 1, and variations of this trig identity is that sine squared theta equals 1 minus cos squared theta, and cos squared theta equals 1 minus sine squared theta. We also saw that tan theta equals sine theta over cos theta. Now the next thing, well, in year A2, what we've looked at is we've looked at that 1 over tan theta is cot theta, 1 over sine theta is cosec theta, and 1 over cos theta is sec theta. And we could also know that cot theta is also equal to cos theta over sine theta. Now in terms of new trig identities that we've discovered, it's going to be that sec squared theta equals 1 plus tan squared theta, and we know that cosec squared theta equals 1 plus cot squared theta. Now from obviously variations of this, we can say that tan squared theta is going to be equal to sec squared theta minus 1, and we also know that cot squared theta is going to be equal to cosec squared theta minus 1. And again, the key things is that we need to look at. Now you might obviously be using that, for example, 1 over sine squared theta squared is going to equal 1 over sine squared 1 over sine theta is cosec theta, so that's going to equal cosec squared theta. And obviously that then applies for 1 over tan squared would give you cot squared theta, and 1 over cos theta would also give you sec squared theta. So just little things like that that you need to be aware of. Now in this video what we're doing is I'll be showing you a one potential solution for the 16 questions. Now the key thing to remember when it comes to trig identities is that there is always going to be more than one way of proving these statements, and as long as you are mathematically sound and correct, then you should get full marks for it. As I mentioned earlier, there may be some quick ways and some long ways of doing it, but as long as you show them correctly mathematically, then it's going to be absolutely fine. And like I said before, that there are different ways in which you can prove a trig identity, and that's by either making left hand side equal to the right hand side or vice versa, or taking the entirety of one side over to the other side and showing that it does equal 1. Now we'll put a copy of these questions in the description below for you to download and have a go, and then obviously you can then watch this video on some of the questions that you found particularly tricky. So let's have a look at some of these solutions then. So for question 1, it says we've got to prove that sine theta tan theta plus cos theta equals sec theta. So looking at this, I'm going to take the more complicated side, so I'm going to take the left hand side, and again what I'm going to do is just make sure that I'm identifying which side that I'm actually working with. So with this, the only thing I can really change is the tan theta. So if I just write down the left hand side, which is always good practice, and also making sure that I'm copying it correctly. So there we go. And so the only thing I can really change is this tan theta. So I'm going to write sine theta over sine theta cos theta plus cos theta. And then from this, what I can then do is simplify that line, so I get sine squared theta over cos theta equal plus cos theta. And then from this, I can then kind of combine this into one simple fraction. So I've got sine theta or sine squared theta over cos theta plus cos squared theta over cos theta. So again, just trying to get it all as a one common fraction. And then if I just move over here, now if I see in an exam, I wouldn't try and fit it, I'm just trying to fit it on the screen. I personally would continue working down or just get more paper. So from this, I've got sine squared theta plus cos squared theta. Because I've got common denominator, I can have it all over cos. Now this here is our trig identity, where I know that from A2, so that equals 1. So what I've then got is 1 over cos theta, which then equals sec theta, and that equals the right hand side, and then QED. So any of those kind of expressions would be absolutely fine for that. And again, if you've done it another way, that's absolutely fine. This is just one way of doing it. Let's have a look at our second problem. So in our second problem, it says that we've got cosec theta plus tan theta sec theta equals cosec theta sec squared theta. Bit of a mouthful there, but let's have a look. So looking at this, the more complicated side I can work with, well, I can either take either or questions actually, because there is a trig identity for sec squared theta. There is also, in terms of cosec, tan and sec, there's a lot of similarities there. So let's have a look at the left hand side, because usually speaking, let's get a little pen so you can actually see it. Let's go for pink. So we've got the left hand side is what I'm going to take. So I'm just going to write that out again. So I've got cosec theta plus tan theta sec theta, and there we go, and this is what I want it to eventually look like. So from this, I've got cosec theta, which is 1 over sine theta, plus tan theta, which is sine theta over cos theta. And I'm going to put a dot, because I use dot product, I tend to use it more in America, but again, it's really actually useful for doing, particularly with identities, rather than writing multiplying, because then you start messing around with the get confused in terms of operators. And sec theta is 1 over cos theta. So then from the next line, all I've got to do is simply combine this second term. So I've got 1 over sine theta plus, and then from this I'm going to have sine theta over cos squared theta. Now from this, what I'm then going to do is to try and join these two things together. So what I've got is cos squared theta plus sine squared theta over, and then obviously a common denominator between these two fractions is going to be sine theta sine squared, oh, no, sine theta, and I'm going to end up with cos squared theta. And then from this, I can notice that this top line is going to equal 1. So I've got 1 over sine theta cos squared theta. If I break that up, I've got 1 over sine theta times 1 over cos squared theta. This is going to give me my cosec theta, and this is going to give me my sec squared theta. And there I've proved my right hand side, or done my bit of Latin. And there we go. Now again, like I said, there are different ways in which you could do this. So if you've done it a different way, as long as it's correct, boom, you are happy. Now with question 3, what I'm going to do is I'm going to take the right hand side and show that it's equal to the left hand side. So first things first, let's write down what sign I'm working with. So I've got cot theta, cos theta. Now obviously I want to try and get 1 over sine and sine theta. So I need to try and convert these two things so they involve nothing but sines. So for this, what I'm going to do is I'm going to replace the cot theta with 1 over tan theta, which is cos theta over sine theta. And I've got that being multiplied, so I'm just going to use a dot as a dot product being multiplied by cos theta. Now from this, I can then combine the two cos thetas to give me cos squared theta over sine theta. Now using one of the identities of cos squared theta, I've got 1 minus sine squared theta. And that's all over sine theta. So now I've got nothing but sines, which is exactly what I'm wanting. Now if I split this up, I get 1 over sine theta minus sine squared theta over sine theta. And you can pretty much see what's going to happen. So I can cancel the square with the sine underneath. And what I'm left with is 1 over sine theta is cosec theta and minus sine theta. And that equals the left hand side Q D. So moving on to question 4, we've got sine theta plus cos theta all squared minus 1 equals 2 sine theta cos theta. Now the one that looks more complicated is the left hand side, so that's what I'm going to take. So I'm going to write the left hand side and I'm just going to write the question out again. So I've got sine theta plus cos theta squared minus 1. Again, don't forget that minus 1. Now the key thing to remember is that this is not sine squared theta plus cos squared theta, which is just equal 1, because 1 minus 1 is equal 0, and that's where we're going to end up with a mistake. So we need to remember that this is going to be a double bracket, so it's going to be sine theta plus cos theta multiplied by sine theta plus cos theta minus 1. And then expanding those double brackets, I get sine squared theta plus 2 lots of sine theta cos theta. If you want to write cos theta sine theta, that's absolutely fine, whatever floats your boat, minus 1. And then if I rearrange this, I've got sine squared theta plus cos squared theta plus 2 sine theta cos theta minus 1. This equals 1, so I've got 1 plus 2 sine theta cos theta minus 1. The 1 and the 1 cancel out, which then leaves me with 2 sine theta cos theta, which equals the right hand side Q E D. And job done. So let's just have a look at number 5, and let me just quickly label it as well. And there we go. So let's have a look at question 5. So again, with question 5, what I'm going to do is I'm going to take the left hand side. So from this, the left hand side, I'm going to write it out again. So I've got sine theta cosec theta all squared. And again, expanding that out, I'm going to get sine squared theta minus 2 lots of sine theta cosec theta plus cosec squared theta. Now from this, what I could then do is start using some of the trig identities. So I'm going to keep my sine squared theta. There's not much I can do with the minus 2 sine theta at this moment in time, although we'll come back to that. Plus, but I'm going to change the cosec theta into 1 plus cot squared theta. Now, because obviously I'm wanting a cot squared in my final answer. Now my next line then is going to be sine squared theta plus 1 plus cot squared theta minus, and then here I'm going to work with this, in which I've got 2 sine theta, and then cosec theta is going to be 1 over sine theta, in which that's going to cancel with that. So all I'm left with is my 2. So then here I've got sine squared theta plus cot squared theta, and obviously the plus 1 and the minus 2 gives me minus 1. So that then equals the right hand side, Q, B, D, and jobs are good in. So now let's have a look at question 6. Let me just turn on the screen so you can actually see it. So again, I'm going to look at the left hand side. Now the key thing to spot with this particular question is the fact that this is dots. So what this is going to do is have just write left hand side, and again I'm going to do it, just quickly write it down. Is going to equal sec squared theta minus tan squared theta. Now it is important you do write in that way, because obviously the first term in your dots is going to be your positive one, and your second term is going to be your negative expansion. So from this, what we can then do is work with sec squared theta, because that there is our trig identity. So that's going to give me 1 plus tan squared theta minus tan squared theta. If I expand the brackets, these two things here are going to cancel, which just leaves me with 1, which therefore equals the right hand side, Q, E, E. And looking with question 7, so again with this, what I'm going to do is I'm going to take the right hand side this time, because obviously I can work with expanding brackets. So looking at the right hand side, and again let me just quickly write that all down. So I've got sec theta plus cos theta, and I've got sec theta minus cos theta, and again this is again going to be dots, so that's going to be sec squared theta minus cos squared theta, and obviously this then is going to give me 1 plus tan squared theta, and minus, and this is going to give me 1 minus sine squared theta. And expanding the brackets, what I end up with is 1 plus tan squared theta minus 1 plus sine squared theta, and then the ones will cancel out, leave me with just tan squared theta plus sine squared theta, which equals the left hand side, Q, E, D. So moving on to question 8. So again here I'm going to take the left hand side and change colour pen. So I'm just going to write that down. So I've got sec squared theta plus cot. Oh, let me just get rid of that, and also just change that to square. That's me, which is not. There we go. And we've got cot. What's this doing now? There we go. Cot squared theta. So from this, what we can then do is take the left hand side, which we've done. I'm going to change this to 1 plus tan squared theta, and also change this to cosec theta, squared theta rather, minus 1, and we've got a plus there. Then obviously the ones cancel out, leaving me with just cosec squared theta plus tan squared theta, which equals the right hand side, Q, E, D. Looking at question 9. So again, what I'm going to do is take the most complicated side, the one with the brackets, which makes it more easier. So I'm going to take this left hand side, and let me just quickly write it out again. So I've got sine theta plus cos theta. If you find that what I'm saying is different to what's on the screen, what's on the screen is going to be true. It's just multitasking can be a little bit more confusing. Right, so looking at expanding these double brackets, what I end up with is going to be sine theta minus sine squared theta cos theta plus cos theta minus sine theta cos squared theta. Now from this, what I then want to do is start working with trying to get it something with regards to what the right hand side looks like. So what I'm going to do is I'm going to change this. So I've got sine theta minus 1 minus cos squared theta cos theta plus cos theta, there's nothing else I can do with that, minus sine theta. I'm going to change this to 1 minus sine squared theta. Then from this, if I just expand the brackets out, so I've got sine theta minus, and then it's going to be cos theta plus cos cubed theta, and then plus cos theta, and then minus sine theta plus sine cubed theta. Now from this, I've just got to try and cancel things that cancel out. So this positive sine theta is going to cancel with a negative. This negative cos theta is going to cancel with that. So all I'm left with is cos cubed theta plus sine cubed theta, which equals the right hand side QED. Then looking at question 10. So again, with question 10, what I'm going to do is, again, it doesn't really matter which side you want to pick, but I'm going to go for the left hand side. So just quickly writing that again. So tan 4 theta plus tan squared theta. And then from this, I'm going to use the trig identity of tan squared theta, which is sec squared theta minus 1. And then because it's to power 4, I'm going to square that. So because obviously this is, just quickly write that down. So that there is tan squared theta squared. So obviously, because obviously when you multiply, you add the powers, and there we go. So from this, what I've then got plus, and obviously, so for this, I'm going to change that to plus. I'll put it in brackets so you can see what I've done. So I've got sec squared theta minus 1. Then simply expanding the brackets out, remembering that this is going to be a double bracket. So I've got sec 4 theta, and it's going to be minus 2 lots of sec squared theta, and plus 1 plus sec squared theta minus 1. And then from this, what we're then going to do is just simplify. So this will cancel with one of those, that plus 1 cancels with that, and so all we're left with is sec 4 theta minus sec squared theta, which lo and behold is our right hand side QED. Then looking at question 11, so with question 11, what I'm going to do is I'm going to take the left hand side. So let's go for blue this time, so left hand side, and just quickly write out the question. So cos 4 theta minus sine 4 theta. And again, from this, we can then see that this is going to be a dots. So from this, we've got cos squared theta minus sine squared theta, cos squared theta plus sine squared theta. And from this, we know that this is equal to 1, so I've just got 1 lots of that, so it's just going to leave me with cos squared theta minus sine squared theta, which equals the right hand side QD. Now looking at question 12, here I've got a fraction. Now most of you would be very, very tempted to take the numerator over to the other side, so that we end up with sine theta plus cos theta multiplied by sine theta minus cos theta, which looks like which will be a dots question, and we've got equals 1 minus 2 cos squared theta. Now again, we don't want to be doing that because you can't take snippets of the right hand side over to the left hand side. You're just going to take all of it over to the other side. So what I'm going to do is I'm going to take all of this over to this side, and by doing that, I'm going to just basically, what I'm going to be doing is dividing both sides by the right hand side and show that it equals 1. So what I'm going to do is I'm going to prove that sine theta plus cos theta divided by 1 minus 2 cos squared theta over sine theta minus cos theta equals 1. That's what I'm now going to prove. So if I just put the 1 in a bubble, because that's what I want to prove. And now again, when we're dividing, we flip the fraction. the second fraction and change the division into a multiply. So what I end up with, I'm going to use brackets, multiplied by sine theta minus cos theta over 1 minus 2 cos squared theta. I don't know what I'm doing with that little line, so let's get rid of it, like so. And then obviously what I could then do is expand these two things. So that then is going to equal sine squared theta minus cos squared theta over 1 minus 2 cos squared theta. Now what I can do from there is I can then change the sine theta into 1 minus cos squared theta minus cos squared theta. That's all over 1 minus 2 cos squared theta. If I simplify the numerator, I end up with 1 minus 2 cos squared theta over 1 minus 2 cos squared theta, which lo and behold equals 1, and I've then gone on to prove what I've wanted to prove. So looking at question 13, so here we're going to take our more complicated side, which in this case is our left hand side. So let's just start by writing that out, making sure that we are copying it up correctly. Over sine theta. So first thing I'm going to do is try and get a common denominator, because obviously there's nothing really I can simplify and swap in terms of this. I can't think of tan with our first bracket because I've got that 1, nor can I get cot because I've got that 1 plus in front of it. So here what we're going to try and do is, first things first, is let's just try sticking it all as one fraction. So what we're going to do is we're going to multiply this first fraction by sine theta, and we're going to multiply this second fraction by 1 plus cos squared theta. So let's just write that down. So multiply this by sine theta, and we'll multiply this one by 1 plus cos squared theta. Try and get that common denominator. So what I end up with is sine squared theta plus 1 plus cos theta squared all over 1 plus cos theta sine theta. And then from this, what I'm then going to do is expand the brackets on the top. So I'm going to leave the one to the bottom. Obviously I can't cancel this through because obviously the sine squared theta here is stopping me from cancelling that 1 plus cos theta, although it may be very tempting. It'd be a very immature mistake to make. So I've got sine squared theta. Expanding that bracket, I get 1 plus 2 lots of cos theta plus cos squared theta. And that's going to be all over 1 plus cos theta sine theta. Then from this, what I can then do is slowly start to rearrange things. So here what we've got is, I'm going to have, recognizing I've got sine and cos, sine squared plus cos squared is going to equal 1. So I've got 1, and then I've got plus 1 plus 2 cos theta, and that's all over 1 plus cos theta sine theta. Then simplifying that numerator, I get 2 plus 2 cos theta over 1 minus cos theta. And then we just get rid of that rogue bracket. There we go. And then from this, I can factorize the numerator. So I've got to take a 2 out. So I've got 1 plus cos theta. And if I put the denominator in brackets as well, we can notice, and again, I've also, stick a sine theta from there. And I've got my sine theta. And then from this, I can see that this will cancel with this, leaving me with just 2 over sine theta, which is 2, 1 over sine theta, which equals 2 cosec theta, which equals the right hand side QED. And boom. So let's have a look at question 14. So looking at question 14, I've got cosec over cot theta plus tan theta equals cos theta. So again, I'm going to take the left hand side. So just start by writing that out. So I'll get cosec theta over cot theta plus tan theta. And again, from this, what I'm going to do is just make this look like a complete mess of a set of fractions. So cosec is 1 over sine theta, all divided by 1 over tan theta plus sine theta over cos theta. Then from this, what I can then do is switch the 1 over tan theta. So I've got 1 over sine theta, all divided by, and that's going to be cos theta over sine theta plus sine theta over cos theta. which then becomes again 1 over sine theta all over sine squared theta plus cos squared theta, all divided by sine theta cos theta. Because what I've tried to do there is for all of this is try and get a common denominator. So my common denominator would be sine theta cos theta, and obviously you multiply the first fraction by cos theta and the second fraction by sine theta, and that's what you're going to get. And then from this I've got 1 over sine theta equals 1 over sine theta cos theta, and from this I can then, to make it so you can clearly see what I'm doing, so I've got 1 over, actually that's going to be sine theta cos theta over 1, and multiplying. Then obviously things start to cancel out, so that sine will cancel with that sine, leaving me with just cos theta, which therefore is the right hand side, QED. So let's have a look at question 15. So again, with question 15 I'm going to take the left hand side, and so let's just quickly write that up in not the most neatest of handwriting, but hopefully it will make sense to you. So from this I'll write that as 1 over sec squared theta plus 1 over cosec squared theta, and then I can write this as 1 over cos theta or cos squared theta plus 1 over sine squared theta, and then that then becomes, let's just write up here so we've got a bit more space, so that then becomes cos squared theta plus sine squared theta, which is the trig identity, which equals 1, which equals the right hand side, QED. So moving on to our last trig identity, let's have a look at this one. So what I'm going to do again is take the left hand side. So let's just do just that. So I've got 1 minus sine theta over cos theta. Now there's not really much else I can do with this. The only trig identity that uses single sine and single cos is tan. So let's try that. So I'm going to end up with 1 over cos theta minus sine over cos theta. And that's going to give me 1 over cos is sec theta minus sine over cos is tan. Now there really isn't much I can do with this, but one thing I do notice is that this times by this will give me 1. Now if that's the case, then obviously we need to borrow something from the right hand side. Then this is when you need to do the left hand side over the right hand side and prove that it equals 1. So what I'm going to do is I'm just going to kind of just put a line through this, and what we're going to do is we're going to divide both these two things. So we've got 1 minus sine theta over cos theta divided by 1 over sec theta plus tan theta. I'm going to show that this equals 1. So from this, so again what we've done is just taken that over to the side. So from this we can then follow what we've done here, and we showed that this was equal to sec theta. So let's just quickly do that again. So I've got 1 over cos theta minus 1 over sine theta over cos theta, which then becomes sec theta minus tan theta. I'm just going to put that in brackets, and then we've got that divided by 1 over sec theta plus tan theta, which then turns into a multiply, flip the second fraction, over 1. So then what we end up with is sec theta minus tan theta multiplied by sec theta plus tan theta, which then leaves me with sec squared theta minus tan squared theta. Now from this we can use the trig identity of that 1 plus tan squared theta minus tan squared theta, which then becomes 1. And there we have proved that that's going to equal, well there we've proved the left hand side over the right hand side equals 1 QED. And there we go.